Welcome to my channel. This video focuses more on programming. When I first started looking into Arduino Audio, it was because I wanted to make a voice changer. The next step was to figure out how to process audio. However, none of the modules I ordered have arrived yet, so I'll start by working on the programming part. After looking through some examples, I formed a vague idea of how it works. On GitHub, I found a project specifically for Arduino audio development called Arduino-audio-tools. When I checked out the repository, I realized I had hit the jackpot. It's actively maintained by many contributors and has had several recent updates. The other related libraries I found before were quite outdated, which made me think no one cared about Arduino Audio anymore. After downloading the project and studying it a bit, I discovered that it even supports desktop testing. That means I can run tests even without having any hardware modules in hand. However, it's been quite a while since I last wrote C++ professionally. Back then, my main tools were VC++ and Unity. I'm too lazy to download either of them now. They're huge, and every update requires a full re-download. Whenever I wanted to do a quick test before, they always needed to update first. Later, Unity changed its pricing policy and refused to renew the testing account I had been using for several years. Around that time, I also gained access to a Linux server, so I stopped installing those tools altogether. So, I decided to use WSL, Windows Subsystem for Linux, as my development environment. Developing C++ programs on Windows used to be a pain. It didn't have a free compiler like Linux does. Even when using MinGW, I often ran into missing library issues. On the other hand, the VC environment is more straightforward when it comes to linking complex and diverse libraries. Therefore, the make command is still quite new to me. So, I looked for a simple Hello World project to practice writing a cmakefile.txt, including only the minimum required settings. To check the version of make currently installed on the system, you can use the version parameter. Another important configuration is the project name and the programming language type. Since this project will eventually generate an executable file, it's necessary to define the @_executable entry. The simple command used to run make is written in run.sh. The second test project is to enable Ubuntu to play sound. I usually use Linux servers, which don't have audio playback requirements. On Windows systems, the OS supports all devices, so there are unified commands for playing and recording audio. On Linux systems, due to user customization, audio playback requires matching the installed audio player. According to AI search results, the most commonly used audio systems on Linux are ALSA and PulseAudio. Since ALSA appeared first, I decided to test the ALSA program first. I asked AI to generate a simple ALSA audio playback project. AI also listed the required development packages and the compile commands. I organized the development packages into a bash script on GitHub, and the libraries that need to be linked during compilation are written in the cmakefile.txt. After completing the compilation and running the program, I got an error message, no playback device found. Looking back at the original source code, on line 55 the program asks the system to scan its configuration to check if there are any audio playback devices available, but none were found. At that moment, two questions came to my mind. First, does the Windows subsystem for Linux, WSL, actually support hardware devices? Second, if it does, is that support automatic, or do I need to install some software that works together with the WSL system? My research results all pointed to PulseAudio, which was the second option previously suggested by AI. Still, I struggled for quite a while trying to find a workable ALSA solution. I even installed the OpenSUSE version. In its documentation, it says that WSL support is built in. Eventually, I gave in and tested the PulseAudio project. On OpenSUSE, I finally heard sound. At that point, it suddenly occurred to me that maybe on Ubuntu, I could simply switch to PulseAudio and achieve the same result. After testing, it indeed worked. I had gone in a big unnecessary circle. Since my goal is to create a voice changer, I need to modify the original audio source data. Now that PulseAudio is working, I looked at the sample provided by AI. It reads a .wav file, which is an uncompressed audio file. Based on other Arduino-related reference materials, almost all of them mention 44,100 Hz, 16-bit PCM format. When converting audio files in an audio editing program, I also convert them to this format. Looking at the PulseAudio source code, it uses the same header structure for reading audio files as ALSA player. After the header, the rest of the file should be the actual audio data. I created an audio clip and saved it as an 8-tone .wav file, and another one with only 2 tones. In theory, the audio data portion should be the same. However, when I opened the files in hex mode, they didn't look quite the same. I needed to confirm where exactly the audio data begins in the file. So, I added a section in the loop function to output the contents of the buffer in hex mode. By comparing the output data, I found that the first 1024 bytes read from both files mostly the same. Not all. Finally, it's time to test the Arduino-audio-tools desktop version. Since I had been testing .wav files before, I thought the player wave project in the testmake directory would be a good fit. CMake generated the executable player wave, but when I ran it, the ALSA player error appeared again. It couldn't find a playback device. The Arduino project uses ALSA player by default. Judging from the code, the ALSA structure is a bit simpler. The problem is that even after installing ALSA player on WSL Ubuntu, it still couldn't run properly in previous project tests. Is there a way to change the system's audio player? The Arduino-audio-tools player wave initialization uses PA_open_default stream function, which is a PortAudio function. After downloading PortAudio, I took a quick look at it. It collects a lot of different audio player libraries. It functions more like a management type application. In the host AP directory, you can see folders for both ALSA and Pulse Audio. In the PA_open_default stream function, it retrieves the system device using PA_getDefaultOutputDevice. Inside PA_getDefaultOutputDevice, it calls PA_getDefaultHostAP to get the audio player. There's also a global parameter called defaultHostAPI_index_, which appears to be set in the initializeHostAPIS function. It looks more like the program reads a configuration value. So, when the program runs, it depends on what the system can detect. To check that, I decided to look it up using system commands. Luckily, I found someone who had asked about audio I/O issues. I ran all the suggested commands, but didn't see any information about ALSA or Pulse Audio. At least so far, I've confirmed that Pulse Audio can run. Originally, I wanted to switch to using Pulse Audio in the program, but unfortunately, the system couldn't detect anything related to it. So I looked for another approach. Could Pulse Audio replace ALSA? After some investigation, I found that Pulse Audio is actually built on top of ALSA. Previously, I had installed ALSA development and Pulse Audio development, but I hadn't installed Pulse Audio itself. After installing Pulse Audio, the Arduino-audio-tools testmake/player wave program was finally able to run. Just recording this unexpected journey here. See you in the next video.